My name is Ali Megahead, and I'll be presenting our work entitled Analytics for the Engagement Lifecycle of IBM's Highly Valued IT Service Contracts. Let me just say that this work has been done across multiple teams in IBM, so it's a joint effort between these teams, and it has taken us multiple years doing this. Now, these people that you see representing this submission are kind of the team leads for the teams that have been doing the work we will be presenting. So it's myself from IBM Research, along with my colleagues from Research, Hamid Mutahari, Pei Fong-yen, and Taiga Nakamura. And then we have our business partners from the business side of IBM. We have Mark Smith, who is presenting with me, and Doug Smith. And before I continue, let me thank the judges for giving us that great opportunity to be a finalist, which we're very delighted for. Okay, so what is this about? Well, our inventions or work addresses the general problem of sales pipeline management. And what that is these are the kind of businesses or applications where there is a tender kind of deal competitive environment. So what happens is the client would have some request for delivering some services, and the client would have a request for proposal. Now, different providers of these services would prepare a response for that proposal and try to compete against each other to convince the client to take their proposals, until the client first down selects some of them, and then those down selected providers engage with the client in a negotiation process in order to convince him to take their solutions against their competitors. Such kind of applications arise in multiple businesses, including our business. And it's usually characterized, or it can be thought about as this kind of funnel diagram where there are multiple opportunities in the beginning, but then we will bid on some of these opportunities, we will not bid on others. And then the ones that we would bid on, we will keep working with the client, trying to close them to hopefully win them, but we will not win all of them. And then, so as time goes, that gets down to lesser opportunities until at the end we would win some of them and we would not win the rest. Sometimes we lose to competitors. Some other times the client at the end decides to not pursue such a deal anymore. Some other times the provider decides to not pursue the deal because they find it's not a good fit. Because such an engagement process might take really, really long time, and it could be very costly to just make a response for these proposals. And then, so if you find that you might not win these deals at the end, so why waste time and money and resources in preparing that response and engaging with the client? However, as you can imagine, either this question, which deals to pursue and which to not, or multiple other questions might arise that are very difficult to answer, and if you answer them subjectively, you might be losing a lot of money. And some of these questions that I will just outline very quickly are, for example, in the beginning, when you identify your opportunities, how would we map the RFP is the request for proposals? How would we map the request for proposals from clients to the actual offerings that we do offer as the provider? And then, how do we validate and qualify deals? Meaning, which opportunities should we pursue and which should we not? Because as I said, it might take time and money to just pursue these opportunities. So if you're not winning, don't waste your time. How would we price these deals so that we increase our chances of winning? How can we predict the revenue out of the ones that we predict that we would win? And then when we pursue such opportunities, how do we form a winning team? How do we predict the deal outcome, which deals we would win, which deals we would lose? How can we assess the competitiveness of our prices against our competitors so that if something needs to be done to adjust it, to increase our chances of winning the deals, we better do it? And also, how do we monitor the status of our opportunities? Because it's not only about predicting whether we would win the deal or not, but we would like to monitor the status and predict what's the next thing that will happen in the deal is, so that if it is not healthy, it's not going as it should compared to what we have seen in the past, then we better take an action to make it go better. And then we go close to the contract stage where we would still like to predict which deals would definitely be won and which won't, and as well predict the revenue. And then after we win any deal, we start delivering those services to the clients. Now, the work that we do lies in this area, which is what we call the engagement lifecycle, rather than the delivery part. And now that I talked about the general problem that arises in multiple industries, let's take a deep dive in how that looks in IBM's business. But before which, let me state what we do here. What we do is that we are bringing analytics to transform the subjective, time-consuming business judgments into informed decisions based on data-driven insights. So now let's deep dive into how that business is for IBM's application that we are concerned with. I'll hand it to my colleague Mark to talk about that.
Hello. Good afternoon, everybody. My name's Mark Smith, and I'm the business support really to Ali. So Ali's the technical from IBM Research, and I'm from the business and set the business requirements for a number of the opportunities we're going to see here today. What I wanted to just quickly do here is just set the context of what we're talking about. So we've talked about IT in IBM's highly valued IT services. So what do we really mean by that? Yeah. To put it into perspective, in this area of the business within IBM last year, we signed $17 billion worth of business. That would be spread across hundreds of engagements. Some of those might go down to hundreds of thousands of dollars, but others might go right up to being $1 million plus on a single engagement. So when Ali's talking about it costs us a lot to engage, on the larger engagements, it can cost us $100,000 to actually engage over the life cycle of an engagement. If we lose that at the end, that's dead money, gone, $100,000. Yeah. Because our focus here has been on contracts that are over $10 million, so we're focusing on the larger deals. Because they're big, complex deals, then they take a while to engage. The smaller ones may complete in 3 months, but more typically you're talking sort of 6 to 12 months, and sometimes they can actually go over the year. So it's a protracted engagement with the client where there's many iterations of costing and pricing and negotiations before finally getting to a contract. And again, because they're high valued, then there's a lot of competitors out there. So people like HP and the Indian competitors and Wipro, we're all there. And there's a pool of us that turn up on a lot of these deals. So highly competitive. The deals themselves are really what we call outsourcing. We're talking about IT services contracts. But outsourcing of the client's entire IT infrastructure. It may also include application development as well. But if I go back to the infrastructure side, it might include such services as the cloud, mobility, Intel, some of the more legacy type things, mainframe, network services. And then because it's a managed service, then we also wrap service management around that so that we can track SLAs, manage change on the contract, and other type activities, and governance. We have to manage the contract itself and those responsibilities. And again, because they're high-value contracts, client and IBM don't want to go through this every single year, so they tend to have a longer duration. So they're 5 or 10 years in duration, which gives a lot of revenue, a lot of recurring revenue for IBM year on year. So very, very important to our business. So that's the sort of size of it. In terms of the complexity, we talked about, very briefly, a few services here. We sort of have 26 key services that we have at a sort of a high level. Within every one of those services, then there'll be a number of sub-services. Yeah, so in terms of service management, for example, you're going to have some service delivery managers, you're going to have some people doing SLA management, Yeah, there's a number of things. So within each of those 26, there may be 10 sub-services. Within each of those sub-services, that probably breaks down to another set of elements. So you've got another 10 within each of those. So you're then up to about 2,600 elements. So when we actually engage and actually get through to creating a cost case and solution for the client, it's typically about 10,000 lines long. So the challenge from our business is how do we take that amount of detail, 10,000 lines from a big engagement, and then compare that against all of the other engagements and historical data that we've got, making sure we're comparing apples with apples rather than just comparing apples and pears. And that's the sort of challenge that we've aimed to address at various different parts of the process, as Ali will elaborate on a little bit more now.
All right, thanks, Mark. So now, hopefully you have seen the complexity of the problem and its value as well. What we have done, and I'll summarize here the kind of different analytical tools that we have built through the previous years and we have been using with the business and generating a lot of value. I'll summarize them first and then I'll dig a little bit into each of them because there's no time to go into details in each of them. But then, to summarize them, the first capability or tool that we're talking about is the request for proposal analytics. So how can we take the client proposal and automatically map it to the services that we do offer, and then create a response to such proposal. And that's some kind of a descriptive analytics tool that we developed, and I'll talk about it in a minute. And then afterwards, how can we price to win? How can we price these deals? And for that, we developed a complex algorithm and web application based on it that uses some prescriptive analytics, and not only that, but also predicts our chances of winning at different pricing points that such algorithm recommends. That's why this tool is kind of a prescriptive and predictive analytics together. The next one is the Salesforce resource allocation. So after we decided which deals we want to pursue, we would like to optimally allocate our sales team to the different deals given the different constraints of resource allocation. So for that, we have an optimization model, which is some kind of a prescriptive tool to do so. The next one is, now we are engaging with the client, we are pursuing the deal, and we would like to assess the competitiveness of our price. We would like to see how good are we doing. We would like a tool to give us some kind of what-if analysis. If we take this service out, if we put that sub-services in, if we do different kinds of things, what would happen and how our chances of winning the deal would be accordingly in order to increase our chances of winning such deals. So that's a descriptive tool in that regard. The next one is deal win prediction and sentiment analysis. So we are engaging in multiple deals. We would like to know which ones we would win and which ones we would lose, obviously. And for that, the first part, the deal win prediction, is a predictive tool. And then the sentiment analysis is some kind of a visualization tool where we monitor the health status of the different deals to see how they are performing so far. And then the next one is the deal progress monitoring. And what the idea here is that in the deal win prediction, we just predict whether each opportunity would be won or lost. But then we would like to also monitor how these deals are progressing. There are several milestones that are achieved through the engagement process, and we better monitor to see whether we are achieving them at the right times or not. Because if not, then we need to take an action to increase our chances of closing them successfully. And for that, we came up with the deal progress monitoring tool that predicts what is the next milestone to achieve and when would we achieve that next milestone. Last but not least is the sales pipeline revenue prediction, where we obviously try to predict the aggregate overall revenue out of all opportunities in our pipeline. And for that, we came up with an approach that uses an optimization module into a predictive analytics model. That's why it's a predictive and prescriptive kind of model. And as I said, I'll go briefly into each of those now. But before I leave this, let me just say that there are multiple data sources that we have been using into building each of these tools, and that was part of the big challenges that we had. There are prior deals data, offerings that we do, people's profiles to form the teams, services delivery data, and so on and so forth. Okay, so let me now deep dive into the first one, the RFP, request for proposal analytics. The objective here is that we analyze the request for proposals to extract requirements and map to offerings. Now, let me tell you one thing, that in each of the tools that we will be covering, we have really invested a lot of time and came up with innovative ideas and algorithms that turned into a developed probably software or web application that has been used by the business. So there's no way we would go into the deep details of each. As I said, I'll cover just a glimpse on it. However, we have had publications and patents out of each of those, and I have all the references here, so I'll be more than glad to share the public publications that we have published before in each of those tools for any of you who's interested into knowing more details about any of these tools. Okay, so what is then the Rfp Analytics methodology in the very, very high level? The overall idea is that we first get the RFP documents from the client, we process them, and then we we have learned from the historical documents that we had in the past how we can extract requirements out of these documents. So we have the documents and we analyze them to extract which statements look like requirements. That's the first step. The second step is that we also try to come up with the context of these requirements. Because then the third step is that we try to match these requirements that we came up with using their context to the offerings that we have. So we use both the requirements that we define in addition to their context in order to do the best match we could with the offerings that we do offer, and then we generate a solution that has what things we need to offer in that solution and what others we need to do in a customized manner because it does not fit any of our standard offerings. So as you can see, there's a lot of innovations in this approach. There's a novel NLP text analytics approach for client requirement identification. That's what does the first step. The second step, the automated requirement topic identification and requirement clustering. It uses some clustering machine learning approach. The third one is mapping approach for a novel approach for mapping client requirements to our service offerings, and so on. That's a descriptive tool, as you could imagine. We have one publication out of this, and we also filed one patent to the US Patent Office. The next tool that we did is the price to win analytics, and I'll let Mark present this quickly.
Complexity of the engagements. If you look in, it's particularly at the early stage. Sorry. With the complex engagements, particularly at the stages, it's important to get a view of the pricing that we can achieve onto a deal, so that we can set targets for the team later on, and also match that against clients' expectations to understand whether we should be progressing a deal. The traditional method of doing that is just sort of cost and price everything bottom up, and it takes a couple of weeks to do so. We just don't have the time for that. So we developed this capability here that very quickly enables us to be able to estimate the cost and price of solutions from empirical data that we have available to us. So we have two sources of data in here. We have IBM historical deals, so we've got nearly 500 IBM engagements stored on the database, and we also feed in market data from analysts such as Gartner and other consultants. The data we get from the consultants doesn't perfectly match the data that we have in our historical deal data, so we have to develop an intelligent way of actually getting that data into the same format so it matches the data model, so we've got some sort of one data model that we can interrogate for both systems. In this particular case, what we take then, and this is a web-based application at heart that the users can do, either salespeople or solutioners. And there's a number of user inputs that they can put into that complex web-based application. There's obviously what offerings and services that we need to have in scope. There's sort of the quantities of those things. Yeah, so we've got 500 servers of this shape and size, and 1,000 of these, and 500 of those, and there'll be sub-baselines and that type of thing as well. There's complexity factors. How complex do we think each of those relative services are? And then there's a number of things like deal attributes. So that might be something like geography, because we're a global company and the deal might be in Japan, and we want to use Japan data rather than using European data to do those things. So it takes those inputs, and it takes the historical deal data, and then IBM Research and Ali have developed within the application a complex peer selection algorithm that then selects relevant peer data for both historical deals and market data as two work streams into the tool. So it does a lot of peer filtering in order to get a set of peers, and that's not done at a deal level, that's actually done at a service level. Yeah? So we select for different services different sets of peers. Once we've got that set of peers, there's never such thing quite as a perfect match, and we might find that we have got some gaps in the data. For a particular subservice in Japan, we may not have that particular service, or we may not have got that data from a consultant. So then we've got recommender algorithms that work within the tool that actually supplement that data to make sure that we have got all of the bases covered, because we don't want to come out with a prediction that says we think it's going to cost 100 million, but we've left 20% out and the real price should be 120 million. Yeah, it's important that we get to an answer for everything, and a reasonable answer for everything. So this is what this recommender algorithm is all about, and Ali's going to talk about that a little bit more on the next slide, because he'd like to go in a little bit more detail. So once we've then got a full set of those metrics, we then go into this cost minor calculation logic, which then delves down into that data and then calculates not only a set of costs and price at a deal level, to say it's going to be $100 million, but also down to intricate levels of pricing for individual services. So an email user may have a price of this. So we end up with a full set of pricing out of this tool. And I'll let Ali just talk about the recommender algorithm a little bit more.
Thanks, Mark. So, as you can see, this is a complex algorithm, and as a matter of fact, each part of those we had almost a publication and a patent out of. So, again, there's no way we would go into deep details, but on the very high level, the way that recommender algorithm works is the following. As Mark said, we do have the deals that we had selected, the peer deals that we had selected in the previous step, in this step in the peer selection algorithm. We do have the services in the in-flight deal that we are trying to price, and there's not a perfect match. One deal might have some services and might not have the others, and so on. Deal 1 might have service, so the blue ones are the ones that exist in the peer. So deal 1 might have service 1, service 3, but it does not have service 2, 4, and 5, and so on. So what we do is we map this problem to the standard classical recommendation system item prediction type of problem in machine learning. So in that type of problem, I'm sure most of you are very familiar with it. A classical example is what Netflix does, for example. There are multiple users and there are multiple movies. Each user had seen some movies, but he has not seen the others. He rated the ones he has seen. He did not rate the others. So using all that data, and maybe in the more complex such recommendation algorithms, like the ones we're using, they might be using some attributes of the users to come up with the rating. What would that user have rated that movie if he had seen it? And then use these ratings to see which ones he would have rated high and recommend him to watch those movies. And usually, or sometimes it works well. So that's the same idea here. So the mapping we did is our data are the users and the services are the movies. And then it's kind of perfectly matches that recommendation problem, and we recommend these missing values and continue with our algorithm. So that's one part I wanted to touch on. And then again, after that, we have some cost minor calculation logic where we uses the peer data that is now complete to come up with the IBM data price and market data price. But then we have those data price points, but we don't know how good they are. What are the probability of us winning the deals at these different price points or other price points? And for that, we came up with a predictive model where it takes different pricing points, either the IBM price point and the market data price point and any other user input price point. It also takes historical data. There are a lot of attributes that we use. I won't go through all of them. I will only touch on one main attribute that we found, and about the competitors. We found that competitors it makes a big difference which competitors are competing. Not only that, but we came up with a clever way of classifying these competitors. Which competitor offers, for example, networking, which competitor outsources cloud, which competitor offers one service or another, and different other things. All details are in the corresponding paper of this. And then we input all that to the prediction model, and the prediction model gives us something like this. We have the different pricing points, and it gives us the relative win probability for each pricing point. Now, the challenge here is that the price is not the only factor. There are multiple other factors, as you can see. And that is one of the main conclusions or main results that we have seen, that price is not the only factor at all. Usually not the main factor. Price, the way we like to put it is that if we don't price deals right, we will lose them. But if we price them right, there's no guarantee that we will win them. So as you can see from that whole price analytics tool, there are multiple innovations, the detailed peer selection algorithm, the calculation logic also, and the way of augmenting the missing values using the recommender algorithm, and finally the prediction of the probability of winning at different pricing points. We have 5 patents out of this, 3 already filed to the US Patent Office, 2 will be filed very soon. We are drafting them right now. It's a kind of prescriptive and predictive analytics Together, we have 2 publications, one published and one submitted last month. The next one is the Salesforce resource allocation, and what we try to do here is we try to optimally allocate sales resources to the deals predicted to be won. At the very high level, again, we have the same prediction model that I just talked about that gives us a probability score output for each newly qualified deal. So now we try to predict for each deal that we already have a price we will be bidding on with, and we apply that model to all these deals. Previously, we were applying it to just one deal with different pricing points. So we have those for all deals, and also we have some other inputs, the constraints around the sales force and some resource constraints and so on and so forth. They all go in an optimization model that forms the optimal assignment of teams to deals, and we give that along with the ranking of the deals with respect to score to the sales executive. So for this, we are still drafting a patent, but we have one publication published last year, and it has predictive and prescriptive because, as you can see, it has that optimization model and it has that predictive part. The next one is the deal competitiveness assessment, and I'll let Mark also very quickly talk about it.
Yeah, we've got about 10 minutes. Right, deal competitive assessment. Earlier on, we'd got a high-level set of data about the client, but we didn't really know the details. Later on, we know all of the details of the client, and we're putting together a detailed cost case. So we need to be able to analyse that and make sure that that's actually competitive, but to be able to do that iteratively and quickly during the course of a deal. Yeah, prior to having this, it was done by people looking at what their past deal was. Yeah, their one experience in that one geography as what it was. So what we've developed is a system whereby we're using the same sources of data again. So we've got the IBM historical deal data and we've got the market data, but this time we feed in the cost case that we have, the 10,000 lines of detail on it. We then use the same peer selection algorithm to actually identify the peers. And then we do some peer scope alignment. So even when we've got those peers, we may still have to make some adjustments for some of the scope items to make sure we're comparing apples for apples. So part of that is done by the system. And then the user in this complex web-based application that we have is then able to make some other peer adjustments as well. So they might want to take a particular peer out because they know something about that deal that they don't want it to be included as part of that comparison. So once those adjustments are then done, what we then get out of that process is we get a view of the competitiveness for the score for the whole deal, and we also get a view of the competitiveness of each of the individual services. And what that enables us to do is we get sort of this view, which is what we call sort of a level 1 view, which is a deal on a page. So it gives us a summary of the whole deal, and it gives us those quantitative assessments of each of those aspects. We'll then be able to identify which are the high points and which are the low points, and then you can start to drill down. So which ones are we worried about, most worried about, and which ones aren't. So that's very good for the practitioners, but it's also very good for management, that sort of level 1 view. The practitioner is obviously very interested in the level 2 and level 3 because they can identify why those particular costs or prices are out of kilter and then take action at an early stage in the engagement to do this. And typically, if it took us 4 weeks to put together a set of pricing, we were getting this view in the last week. Yeah, now we're able to get it from the moment we've got a cost case because it can turn those costs into prices and give us this view very, very quickly. And from this end, loading here to getting the results out here, it's less than a minute for the user. Ali.
Thanks, Mark. And as you can imagine, this web interface based on that idea is pretty complex. To give you an idea, we had a development team of almost 10 developers that has been working for over a year. Of course, we deployed it into phases, and we are continuing to improve the tool, but they have created all that kind of complex interface that has all those underlying algorithms behind the scenes. That's why the innovation parts here include the first two are similar to the ones in the pricing tool because, as a matter of fact, the underlying peer selection algorithm here in this tool is very similar in concept to the one in the price to win analytics that I mentioned. So that's why the first two parts are just a repetition of what we had in the previous tool. But then there is a new novel thing here, which is a competitiveness score that we came up with. To assess the competitiveness of each service and the whole deal, and also the complex web interface that allows users to do what-if analyses, including and excluding different services, as Mark was explaining. We have one patent on this that was already filed to the US Patent Office. We have one publication, and it's a descriptive kind of tool. The next one that we have is the deal win prediction. And obviously the idea here is that we are trying to predict the tool. What is the difference between this and the one that I mentioned a little bit ago? The difference is that the first one tries to predict deals very early on in the process, just depending on the price and some deal attributes. But that is not enough. When we engage with the client, a lot of things happen that are more dynamic in nature. There are some milestones that needs to be achieved before we can really win such deal or lose it. Milestones like scope agreed on, price agreed on, and things like that. So if we use these attributes and we keep monitoring what's happening and we keep updating our model with the new status of these attributes, we can get a much better prediction as time goes. And that's what we developed this tool for. Not only these attributes that are quantitative in nature, but also there are some qualitative attributes, if you will. The sellers, when they engage with the client, they keep writing comments on what things have been going. We had that meeting today with the client, and the client was not satisfied with that aspect of our solution. We had a meeting today with the client. This went well. This did not go well because of this and that. And we have the historical deal comments. So we built another qualitative-based natural language processing model that analyzes the older comments and maps them to, because we know the status of the deals in our historical database, and we have these comments with a timestamp. So now we can, whenever we get the new sales team people comments and the timestamp of them, we can predict how good that is happening and whether that deal would really close with a win or with a loss. And we give it a score. Same happens with the traditional quantitative model. And then we combine the predictions from both models to come up with one score using which we rank the deals and give that to the sales executives so that they can use that prioritized list to their benefit. For example, if they see that some deals on the bottom of our list, meaning that they have low chances of being won, and they would really interested in winning these deals, so then now they know that there's something wrong going on, and really need to take an action, go and chase those deals and see what's wrong going on and try to really correct that. Because that tool, and we will talk about deployment in a minute, proved to be pretty accurate in such prediction. So now these are the innovation parts of that tool. I don't want to go through them, and we got 2 patents out of it, 2 publications. It's descriptive and predictive. Let me now jump quickly to the next one. This one is the deal progress monitoring methodology. And this one is pretty complex. I invite you to read its paper. It's quite interesting, but it's pretty complex. And I tried here to do my best to outline it again in the very high level. But first, let me tell what the idea here is. The idea is that we don't want to just predict whether we would win the deal or not, but we would like to predict what is the next step that would happen in the engagement process. When would we agree on the price? When would we agree on the scope? So what is the type of this next event, and when would this next event happen? Why are we interested in that? Because that's, again, monitoring the health status of the deal. And knowing how this is going, we can know what's going right and what's going wrong and try to take an action before then. So it's not only enough to predict whether we would win the deal or lose it, but we want to predict these things, the type and timing of the next milestone in the deal engagement process, rather than just predicting whether it will be won or not. How do we do this? We have the historical data with the milestones time-stamped. We used some machine learning approaches to learn 2 sets of weights. The first set of weight, what we do with it is that after we have the new deal that we are trying to predict, we apply these weights to its attributes, to its parameters, in order to compute parameters for a geometric distribution that gives us the estimate of the time interval of the next event. When do we estimate the next event to happen? A probability distribution of that time of the next event. But then that's the timing of the next event. What is that next event? To answer that question, that's the second part. We learned some second set of weights that we apply to the deal attributes to compute parameters of a Dirichlet process, because we modeled that the type of the milestone with the stochastic Dirichlet process. So after we learn these weights, apply them to attributes. So these are our estimated parameters of that process, and then we use that to estimate the type of that next event. Again, that's very high level, but we have one publication and one patent out of it. It's a predictive model. These are the innovations, what I talked about. I don't want to waste time reading them out. And let me go to the last one, the sales pipeline revenue prediction. And what happens here is that we are trying to predict the revenue. The thing is, to predict the revenue, going back to our funnel diagram, we have multiple opportunities. Some of them would be one and some won't. So at any time, at any week, for example, we know some opportunities, but we know that we won't win all of them. So some of them would convert and some won't. So the first thing is that we want to predict the conversion rate. The second thing is that in the next week, we will get more opportunities added to the pipeline, from which some we would win and some we will not win. So we also want to predict that. As a public company, we would love to predict our quarter end revenue ahead of time. So, and to do so, we need to predict both things. What is the conversion rate of the current opportunities, and what are the opportunities that we will get afterwards that will turn into being won? And that second part we call the growth. Now, how do we predict this? We came up with a very novel approach that combines optimization with machine learning. So what we do is, we have the historical data of conversion growth. We came up with a nonlinear optimization model that models that problem, comes up with the optimal weights for the conversion and the growth. It's a nonlinear, non-convex model. There's no guarantee of optimality, but we were able to formulate a linear optimization model that we proved that it can be worse than the nonlinear model into getting the optimal weights that after we apply to the n historical conversion and growth rates, in historical data of conversion and growth rates, we will get our prediction for the conversion and growth rates, apply them to the current pipeline's data to predict the future revenue. The other thing is that I said here, we apply to n historical periods. How do we know n? That's another output from the optimization model. So as you can see, the novelty here is incorporating OR in machine learning and optimizing the number of historical periods, and also the conversion that we did from the non-linear model to the linear one. We had 3 patents out of this. We submitted 1 publication last month, and it's a combination of prescriptive and predictive analytics. To summarize our tools, we had done multiple tools. They span over the different dimensions, 3 dimensions of analytics, as you have seen. And now I hand it back to Mark to talk about business impact.
Okay, just talk quickly about business impact. Just probably the first thing to just say on that is that in terms of the deployment of these tools, so the price to win analytics and the deal competitiveness assessment and the deal win prediction and the revenue prediction that we've talked about here are all fully deployed to the business. The other ones are in the process of being deployed. So we haven't even got the advantages of those yet in the data that we're about to present. Looking back to 2015 and the performance of the outsourcing business, or the highly valued IT services contracts business within IBM, we saw a significant rise in the win rates on the strategic outsourcing engagements. Now, if we were to apply the same win rate that we had in 2014 to the pipeline of 2015, then it can be quantified as saying that we actually got an extra $2.6 billion worth of revenue in 2015. As a result of a multitude of things within IBM. We can't claim the benefit of all of those things, because deals are, price is one aspect to it, relationship with the client is another aspect to it, and there's lots of other key things. But if you were to just say that we took 10%, which is probably conservative of that, then you could say that there's a benefit here of $260 million. Okay, I acknowledge that's very hard to prove, but which is why we didn't go for a bigger percentage. Just looking down at a little bit more detail of this, so the predictive pricing analytics and the deal competitive assessment, that's actually rolled out over 700 engagement users worldwide within IBM. 550 of those were in 2015. And during 2015, I looked to see how much we'd rolled through the deal competitive analysis tool, and there was $80 billion worth of engagements that had gone through that tool. Yeah, some of those we would have choose not to bid on. Yeah, but other ones they would have gone through the entirety of the process. And the deal competitive assessment, the one that enables us to assess the competitiveness of our actual solution, is now a mandatory part of the process for releasing a bid to within IBM. So you can imagine if you're releasing a $100 million deal, we have a fairly stringent process to make sure that the price that goes out the door and we're part of that process now. In terms of the pipeline revenue prediction, that's increased the accuracy of our manual predictions by an average of 17%. So if you took the same set of data and looked at it from the manner of the old method that we used to use and the new method, you get a 17% difference. So it's a 17% improvement on the same data. Sorry? On average? On average, yes. Deal win prediction, if we looked at the 80% of our wins actually fall within the top 40% of the list that comes out of the win prediction tool. Yeah, so the majority, if you take that top 40%, you're going to get 80% of the wins within the tool. Okay, I think do you want to do this? Is this 2 minutes, or do you want to come back to that at the end if we've got time?
We've got about 7 minutes left.
Are we allowed that 7 minutes?
Well, that would like leave no time for
questions.
Okay, so how about we leave this to the end? So we have a video from Tom Gargiulo, which is the Vice President of Global Solutions Integration and Deployment. We will show it at the end because we better take questions. So let's go to... That is the list of the publications and patents that we had that I have been talking about. As you can see, the ones that are published and the ones that are just submitted. Same thing for the patents, which ones were filed, which ones are in progress. That's for the rest of the tools. And just to summarize everything and say how we meet the judging criteria of this award, we can say that we developed that suite of analytics tools. The uniqueness here or creativity can be seen through the 7 published papers and the 2 under review. All of them are peer-reviewed in top journals or conferences, as you can see from the list. We have 11 filed patents to the US Patent Office, and we can get an assertion from our attorney about that. And we have 3 in progress about to be filed. As you can see how our tools span over the 3 dimensions of analytics, with each tool having, some of them having more than one of these dimensions. The value or the impact, I think Mark talked about it and explained how we estimate it to be in the range of 260 millions just in 2015 compared to 2014. And then the last thing I wanted to touch on is that there is a potential for widespread use. As I started explaining in the beginning, this is about pipeline sales management. So any kind of application that has that kind of service delivery contract that goes through a tender or deal process can benefit from the set of things that we have done. Of course, some tweaking might need to be done, but the overall analytical techniques and methodologies could be very similar for these applications. Examples are medical service contracts, financial service outsourcing contracts, and so on. Thank you so much, and now any questions?